सो हेलो एवरीवन, वेलकम बैक टू माय चैनल अगेन। आज का जो टॉपिक है दैट इज़ द सेकेंड लेक्चर ऑफ द चैप्टर मैकेनिकल प्रॉपर्टीज ऑफ सॉलिड। सो फर्स्ट इन द फर्स्ट चैप्टर वी हैव लर्नड अबाउट द स्ट्रेस, स्ट्रेन एंड देयर रिलेशनशिप, राइट, इन इलास्टिक लिमिट, what is the elasticity, what is plasticity, okay, and especially the Hooke's law. In Hooke's law we have understood that the stress and strain are directly proportional, right? Within elastic limit the stress and strain are directly proportional, and from that equation we have learned that stress is directly proportional to strain, and so stress equals to constant. A constant will come and that constant into strain, and this constant is nothing but the coefficient or modulus of elasticity, right? So now this constant or modulus of elasticity, this is called the modulus of elasticity, right? So now in this video we will learn there are three types of generally modulus of elasticity. The first type is Young's modulus, okay. The first type is Young's modulus. Young's modulus of elasticity. So this is the topic of this video. And it is denoted as this. So to understand the Young's modulus, basically we have to apply some stress on a metallic wire, and so that its length will be increased. Remember, its length should be increased by applying a force. Length. So when it deals with the increment of length. Remember that. So that's why. So if I consider a wire, if I consider a wire having initial length was L, okay. Now due to the application of force, or for example you are just putting a load on the wire, let's assume this is the load, or you are applying a force, that is nothing but the load. Load means it's a weight, right? So force or weight I am applying, and that is can be written as mg also, m into g. So due to the application of the load into a wire, we are assuming the length is little bit increases up to here, and this increased length I am taking as delta L, okay. So this increased length I am taking as delta L. So first of all, Young's modulus is nothing but the ratio of longitudinal stress upon longitudinal strain. So what is the meaning of longitudinal? Longitudinal means when the length is increased along, I mean there is an increment of the wire or any metal along its length. That concept is known as longitudinal, right? So the longitudinal stress upon longitudinal strain. So first thing we know, the longitudinal stress is nothing but, stress means it's like a pressure, means force upon area. So I am applying a force and per unit area. So if I assume the wire having a cross section is a circle, so this is the area of cross section. Area of cross section, let's assume this is a circle, so I can take, as it is a circle, so area formula is pi into r square, okay. So force, or I can write as load upon area. So load means its weight itself, so I can write as weight upon area, W by A. If it is vertically downward, then W. If it is horizontally, just force by area, simple. So weight means we know m into g, area means pi r square. Okay, so that is the formula. You can write as either you can write F by pi r square. Okay, for example, if the wire is stretched horizontally, let us assume this is the length, initial length, and we are applying a force horizontally, so then this is the increase in length delta L, for example, right? In this case we will not take mg only will be taken when the wire is vertically downward. Okay, that means load is acting downward, that is m into g. But when there is a horizontal case, in that case we will only take force, and this area is this A. Okay, so now longitudinal stress is this, and so longitudinal strain is nothing but the strain means change in dimension by original dimension. That means here the length is increases, that's why delta L upon L. So now according to Young's modulus formula, longitudinal stress upon longitudinal strain, so Young's modulus is nothing but longitudinal stress, that is F by A, by longitudinal strain is delta L upon L. So do you understand? Longitudinal stress means force upon area, and longitudinal strain is delta L upon L. So if we replace force upon area, will be coming down into delta L, and the L will go up. Okay, so what is the meaning of this? How to define the Young's modulus from here? If I will take a condition, if L initial length is 1 meter, and if I will take the area of cross section is 1 meter square, and after applying a force, if the increased in length is 1 meter, so it is 1, it is also 1, it is also 1. So can I write Young's modulus itself, the force is nothing but the force itself. So that means how to define Young's modulus? So Young's modulus is nothing but the amount of force applied of a unit length of a wire of unit length having unit area of cross section, which is increased by a unit length. So unit length, so 1 मीटर एक वायर का और 1 मीटर इंक्रीज करने में जितना फोर्स लगेगा उसी को हम बोलेंगे यंग्स मॉड्यूलस. उसका मतलब क्या होगा? सो दिस इज द वायर, इनिशियल लेंथ वाज 1 मीटर, ओके, एंड द क्रॉस सेक्शन इज आई एम टेकिंग एज ऑल्सो 1 मीटर स्क्वायर. सो एक 1 मीटर लेंथ का वायर और उसका एरिया ऑफ क्रॉस सेक्शन 1 मीटर स्क्वायर, उसको और 1 मीटर इंक्रीज करने में, दैट मीन्स द डेल्टा एल ऑल्सो इज 1 मीटर, मीन्स फ्रॉम हेयर टू हेयर जितना फोर्स लगता है दैट फोर्स इज नोन एज यंग्स मॉड्यूलस. सो 1 मीटर वायर को और 1 मीटर बढ़ाने के लिए जितना फोर्स लगेगा दैट इज नोन एज यंग्स मॉड्यूलस. दैट मीन्स to increase the length of a wire by double, to increase that, or to the force required, you can say the force required to double the length of a wire is nothing but known as Young's modulus. ओके, सो एक लेंथ को उसकी डबल करने में जितना फोर्स लगेगा उसको बोलेंगे यंग्स मॉड्यूलस ऑफ दैट पर्टिकुलर वायर. ठीक है, अभी इसका यूनिट क्या होगा? इट्स स्ट्रेस अपॉन स्ट्रेन. स्ट्रेस अपॉन स्ट्रेन, स्ट्रेस होता है मीटर, स्ट्रेस मीन्स फोर्स बाय एरिया, सो न्यूटन पर मीटर स्क्वायर, and strain does not have any unit, so ultimate unit is Newton per meter square. Simple logic, stress का जो unit होगा the same unit will be the modulus of elasticity. Now what is the dimension? The dimension of Young's modulus is nothing but the dimension of स्ट्रेस itself, बिकॉज स्ट्रेन का कोई यूनिट भी नहीं होता है, कोई डायमेंशन भी नहीं होता है, ठीक है. सो इसीलिए द डायमेंशन ऑफ यंग्स मॉड्यूलस इज नथिंग बट द डायमेंशन ऑफ स्ट्रेस, एंड द स्ट्रेस मीन्स फोर्स अपॉन एरिया. फोर्स मीन्स ml t to the power minus 2 upon area. Area means l square. L cancel, 1 l cancel, so it is m l to the power minus 1 t to the power minus 2. So this is the dimension of Young's modulus. So this is all about the Young's modulus. So Young's modulus is nothing but it deals with the increase of length. That means when a wire increases along its length, the concept of Young's modulus is applied. Now we will do some numerical to clarify your doubt. Now we will solve a numerical based on the Young's modulus. So as I said, the Young's modulus is nothing but longitudinal stress upon longitudinal strain. So y equals to longitudinal stress, that is force by area, upon longitudinal strain, that is delta L by L. Okay, this is the formula we know. Now force upon area into delta L upon L. Now this is the question. An iron rod of length 2 meters. So I will write down the given data over here. The given data are, okay, the iron rod of length 2 meters, so L equals to 2 meter, having a cross sectional area. So area is given as 50 millimeter square. So 50 millimeter means 10 to the power of minus 3 into 10 to the power of minus 3 meter square. So I am just converting into meter square. Millimeter to meter means you have to divide by 1000. So there are 2000 will be coming because it is millimeter square, right? So now this is the area and it's stretched by 0.5 millimeter. That means how much stretched done, that is nothing but the delta L, or increased in length, that is 0.5 millimeter, that is nothing but 0.5 into 10 to the power minus 3 meter. Okay, now when a mass of 250 kg, so mass is 250 kg is hung from its lower end, calculate the Young's modulus. So mass is given, we know that if we draw the diagram you can understand. The diagram is like this. The diagram is the diagram will be like this. Okay, so the length is 2 meter, the initial length was 2 meter, right? And the area of cross section, area is 50 into 10 to the power of minus 6 meter square, that is the area of cross section. And delta L means from here to here, this is nothing but delta L is nothing but 0.5 into 10 to the power minus 3 meter, and the mass acting downward with 250 kg. So as the mass is given, if we multiply the mass with G, then we will get the weight or force. That means here the force or weight is nothing but mg. Mg means 250 into the G I am taking as 9.8, that will be in Newton. So all the data is now available and we will put the data here, we will get the solution. So the Young's modulus is nothing but force means mg, mg means 250 into 9.8 force done into length, length means 2 meter, length means 2 meter by area, area means 50 into 10 to the power minus 6, 50 into 10 to the power minus 6 into delta L, delta L is 0.5 into 10 to the power of minus 3, right? So if we cancel this, remove that point, this 0 will cancel. Now 25 2s are 50, this 2 cancelled, okay, and we will get this. If you remove this, it will be a 2 will be going there. So the answer is 8 to 16, 190 into 10 to the power of minus 6 minus 3, that is minus 9, it will go as a plus 9. So you can write as 2 decimal changes, 1.96 into 10 to the power 11, 1.96 into 10 to the power of 11. What is the unit? Unit is Newton per meter square. So this is the Young's modulus. So that means from this formula you can calculate easily, very easy formula it is actually. So out of how many variables are there? 1, 2, 3, 4, 5. So there are 5 variables. Out of 5 variables, 4 variables will be given and the 5th one you have to calculate. So in this case, all these 4 is given, you have to calculate the Young's modulus, right? So in other questions, maybe some other variables can be asked by giving other 4 variables, right? So this is how you have to solve the numerical. Let's do another problem. So here we will do the second question. 2 wires of A and B are of same material. The same material means their Young's modulus are equal. Remember, same material, this is the one of the key word. Same material means their Young's modulus is equal. So when we will do the solution, we will first write down the Young's modulus of wire A and Young's modulus of wire B is equal because they are made up of same material. So ये बात हमेशा याद रखना, अगर मटेरियल सेम होगा तो देयर यंग्स मॉड्यूलस विल बी आल्सो सेम. ठीक है, चलो और क्या दिया हुआ है? देयर लेंथ्स आर इन द रेशियो ऑफ 1:2. तो लेंथ आर इन द रेशियो ऑफ LA:LB मीन्स वायर A एंड वायर B का जो लेंथ वो दिया हुआ है 1:2. ठीक है, एंड द डायमीटर्स आर इन द रेशियो ऑफ 2:1. डायमीटर्स आई एम टेकिंग एज DA:DB is equals to 2:1. ठीक है, so when stretched by force FA and FB, so one force is FA, another force is FB. ठीक है, and they get equal increase in their lengths. That means delta of LA and delta of LB are equal. So that means increase of length in A, where A and increase in length and where B are equal. Then you have to find out the ratio of FA and FB. That means you have to find out FA and FB का ratio क्या होगा. That is the question mark. Okay, so now we will solve the problem. Okay, this is the given data I have written here. Now we know the Young's modulus of A is nothing but force into LA by area of wire A into delta of L of A. ठीक है, so first write it down, FA LA by AA into delta LA. That is the Young's modulus formula. So now we know this is what FA into LA. Area is not given, instead of area diameter is given. So we know the area formula, area is equals to pi r square, or you can write as pi diameter by 2 इसका होल स्क्वायर. ठीक है, सो ये क्या होगा? पाई d स्क्वायर बाई 4, पाई d स्क्वायर बाई 4, ये होगा एरिया का फॉर्मूला. ठीक है, चलो अभी एरिया में क्या लिखेंगे? पाई d स्क्वायर बाई 4. सो पाई d स्क्वायर मीन्स DA स्क्वायर बाई 4 ऊपर जाएगा, इंटू क्या है? डेल्टा LA इंटू डेल्टा LA. तो ये हो गया क्या? इक्वेशन नंबर 1. चलो नाउ फॉर यंग्स मॉड्यूलस फॉर द B, मटेरियल B और वायर B, दैट इज नथिंग बट फोर्स FB इंटू LB बाई एरिया ऑफ B इंटू डेल्टा L ऑफ B. ठीक है, सबका B ले लेंगे और क्या करेंगे? FA इंटू LA अपॉन एरिया. अगेन एरिया मीन्स पाई d स्क्वायर बाई 4. सो पाई d स्क्वायर, यार d के बदले में क्या लिखेंगे? DB लिखेंगे, क्योंकि हम लोग B का कैलकुलेट कर रहे हैं. सो DB स्क्वायर बाई 4 ऊपर चला जाएगा, इंटू डेल्टा LB. सो डेल्टा LB, दैट इज द इक्वेशन नंबर 2. Now as I said, Young's modulus of the two materials are equal. So दोनों को इक्वल कर दो. ये भी Young's modulus of A, this is the Young's modulus of B, and two wires are of same material. Same material means their Young's modulus are same. That means I can write equation number 1 and equation number 2 are equal. So make them equal. So FA into LA into 4 into 4 by pi dA square into delta LA is equals to F, this would be B, sorry, this would be B, okay, so this would be B, so FB into LB into 4 upon pi dB square into delta LB. नाउ क्या क्या कैंसिल हो रहा है, इधर 4 4 कैंसिल हो रहा है, पाई पाई कैंसिल हो रहा है, ठीक है। चलो व्हाट आई नीड टू कैलकुलेट, एफ ए इज टू एफ बी, दैट मीन्स आई विल राइट एज एफ ए बाई एफ बी, दिस एफ बी को इधर नीचे लेके आओ तो क्या आएगा ऊपर, एल बी बापुन एल ए विल बी कम डाउन, एल बी अपॉन एल ए, ठीक है। और क्या जाएगा, डी ए स्क्वायर विल गो अप, डी ए स्क्वायर अपॉन डी बी स्क्वायर, ठीक है, डी बी स्क्वायर ऑलरेडी था इधर। अच्छा और क्या जाएगा, डेल्टा एल ए ऊपर जाएगा, डेल्टा एल ए ऊपर एंड डेल्टा एल बी नीचे, ठीक है। चलो और एक एक करेंगे, इट इज नथिंग बट एल बी अपॉन एल ए इंटू डी ए बाई डी बी होल स्क्वायर इंटू डेल्टा एल ए बाई डेल्टा एल बी, ठीक है। चलो एल बी अपॉन एल ए अपॉन एल बी इज 1/2, তাহলে एल बी अपॉन एल ए इज 2/1, दैट विल बी 2/1, it will be 2/1 into dA by dB, dA by dB is 2/1, उसका होल स्क्वायर करेंगे तो 4/1 हो जाएगा, that will be 4/1 into डेल्टा एल ए बाई डेल्टा एल बी, डेल्टा एल ए एंड डेल्टा एल बी आर इक्वल, तो दोनों को कट दो, सो क्या आ रहा है, एफ ए बाई एफ बी is coming as 8/1, so I can write as, so therefore force in wire A and force in wire B are in the ratio of 8:1, that will be the answer, this is the answer, okay, so 8:1 is the answer, this is coming clear over. So this is how you have to solve the numericals of Young's modulus. Thank you, so that's all for today.